Hi students, welcome back to my YouTube channel SADHIK Physics, where we can learn the physics very easily, right. So, recently we started one topic, that is current electricity. In that we already discussed two videos, no. So, one is about the current and another one is about the Ohm's law and definition of the resistance and carbon resistors and temperature dependence, no. Therefore, this all the things, no, we discussed in the previous video, no, clear, right. So, in this one now we are going to discuss the combination of the resistance. No, before that one now we know that we should know like a resistance. What is the resistance formula? Voltage by current. No, therefore, this is measured in terms of like a ohms. So, this is a symbolic representation. So, resistance, what is the formula here? Again, rho into L by A. So, this is rho is nothing but a resistivity, or L by sigma into A. So, sigma is nothing but a conductivity. Now, we can understand resistance depends upon the nature of the material and dimensions and temperature also. So, this resistivity depends upon the nature of the material only, right. So, like this resistors are given. So, resistors are given, therefore, if they are connected in series and parallel or different combinations now, right. So, here resistance we can call it as like a load. So, even our bulb is there, that is also like a certain amount of resistance. Every device it is going to offer some resistance now, right. So, now let us see if these loads or if these resistance no are connected in series and parallel or any circuit way, no, how to solve this type of problems, no, we will discuss in this video now. Now, first let us go for resistors are in series. So, suppose here series connection means what? So, this is one resistor symbol, no. So, this is your first terminal, second terminal, and this second terminal is connected to the first terminal of the resistor, no, and second terminal of the second resistor connected to the first terminal of this one, no. So, this type of combination, no, we will call it as like a series combination, no, series, right. So, these ends now connected to the one battery here, no. So, here we are going to take it as DC only, right. So, that constant current it will be flows. So, here this is having some resistance now R1 and R2 and R3. So, this is here some amount of potential difference or like a battery. Now, what happens now here the current it will be able to flow. So, this can be determined by using the ammeter. You can connect the ammeter here, you can calculate. Now, try to observe this one now, therefore, the current will come here, there is no other path to go, compulsory the same current it will flow through this one now, same current it also will flow through this one now, same current also it will be able to flow through this one now. That means, in series combination no, so in series combination, so therefore, current will be the same across all the resistors, current will be same across all the resistors now. So, therefore, what is going to be divided here now? So, therefore, here the current it will be flowing. So, to cross this one now certain amount of energy lost, right. So, that energy lost, that is nothing but a work is done to cross this one now. So, therefore, certain amount of potential difference is going to loss here no. So, some amount of potential difference is going to loss here no, potential difference we are going to get loss here. That means, so whatever the energy is there no, that energy it will be divided across all these one no. So, therefore, in series combination no, we will be divided so among them, right. So, who is having more resistance, more potential will be takes place no, who is having less resistance no, less potential it will be takes place, clear. That means, so if this is having more resistance no, more potential will be there across this one. Now, if it is less potential, less resistance means less potential will be dropped across this resistor, clear. So, therefore, series combination means these two things no, you need to remember compulsory. So, across them current it will be the same, across them potential will be get divided no. So, we got the current is same, therefore, here current across this one no. So, I is equals to, what is the formula here now? V is equals to IR. So, V is equals to IR, I is equals to V by R. So, therefore, across this one now V by R, therefore, V1 by R1 is equals to V2 by R2 is equals to V3 by R3. This it will be the same in the series combination now, clear, right. So, therefore, potential will be divided now. We know that potential, what is the formula? V is equals to IR1, V2 is equals to IR2 V3 is equals to IR3. Clear? So we know whatever this energy is there, now that energy it will be get divided among this one, no? So V is equals to V1 plus V2 plus V3. Clear? So therefore you can tell that if you take out all these one, no? Therefore if I just replace with the one single resistor connected with the same battery here, no? So this is passes same current, no? So we can rewrite it as equivalent resistance. That means effect of all these one, no, can be represented as like a single resistor, that is nothing but equivalent resistance. So I can rewrite it as I is equals to, so therefore here V is equals to IR, so I into R equivalent, therefore I into R1 plus I into R2 plus I into R3. We know that current is the same, no? So therefore R equivalent can be written as R1 plus R2 plus R3. So in this way, so therefore when they are connected in series, no, so like a lengthwise is connected, no, therefore R is directly proportional to the length. If length increases, resistance also increases, like that. Therefore if they are connected in series, no, so therefore resistance will be increasing. Understand, no? So these all are different, no? Therefore suppose n identical resistors are there, suppose n identical resistors, so resistors are connected in series. So there are n number of identical resistors are there connected, R plus R plus R plus like that, no? Therefore R equivalent can be written as n times of your R. This is your R equivalent. Clear? So therefore here what you can write it now, therefore here okay, what will be the current here across this one now? Current it will be the same across all this one now. What will be the potential across this one now? Potential across any one resistor is nothing but a potential divided by it is N now. Clear? So this is very important formula when they are connected when they are identical resistors are there to N into R. So potential will be divided, that is nothing but battery divided by n number of resistors. That means if all are same, suppose these all are same, so across this one, potential will be the same. So that all it will be divided by equally among the total potential difference. Clear? So these all are about our resistors, no. See, if resistors are connected like this and like this, no, doesn't matter onto this one, no. So therefore resistors does not have any polarity, no, but cells will be having polarity. So wrongly connected it is not possible now. Clear? Right? So therefore now we will go for resistors are connected in parallel. Resistors are in parallel. So therefore here the resistance is there, no, here it is R1 and here it will be the R2, so here it will be the R3. That means all one terminals, no, are connected to one end, so all second terminals are connected to other end. So this is connected to one battery here, no, therefore clear. So one battery here, no, therefore here this is one, no. Now these all are all first terminals are connected to one side, all second terminals are connected to one side now. Suppose here there is a current, it is flowing from the battery now. This current it will come when there is a junction is there now. Therefore this is your current I. So what will happen now? This current is having three paths now. Now therefore three paths, definitely the three paths it will be get divided onto this one now. So through this one now some I1 current it will flowing, I2 current it will be flowing and I3 current it will be flowing now. And all this I1, I2, I3 are again is going to combine here, no. So therefore again if this all combine, no, it will gives us like again I current, no. So I current it will be coming here, no, it will be reaching in this way. Therefore in the parallel connection, no, what you can understand, current will be divided. Clear? So therefore current will be divided, no. Therefore here current is getting divided here now. Clear? So therefore this current will be divided in such a way that the potential difference across this one, potential difference across this one will be the same. Therefore current will be divided in such a way that potential V will be the same now, right? So V will be same. Clear? So these are the 2 points now you need to remember for the parallel connections now. So therefore current will be divided now, and current is divided in such a way that to make like a potential difference it will be the same here now. Clear? Right? So now here total current no, we can rewrite it as current, it will be okay. So potential will be the same no, across this one no, potential will be same, potential will be same, potential will be same. So you know that V is equals to IR. So that means potential will be same no. I can rewrite it as like a I1 into R1, I1 into R1 is equals to I2 into R2 is equals to I3 into R3. This is your condition no. So for the parallel connection. Clear? And here the current is getting divided no. Therefore current can be written as I is equals to I1 plus I2 plus I3. But what it will be the same no. So V will be the same no. So V is equals to so I1 into R1 no. Therefore here I can rewrite it as this is one simple one circuit no. I am going to replace with a one single circuit no. So this is nothing but a R equivalent, same battery, same current should flow here no. Current can be written as like a V by R. So therefore, so V by R equivalent no. Therefore V by R1 plus V by R2 plus V by R3. So V taken cancel out no. Therefore 1 by R equivalent is nothing but a 1 by R1 plus 1 by R2 plus 1 by R3. So that means there will be equal to reciprocal addition will be equal to reciprocal equivalent now. Clear? So in this way, so therefore the equivalent resistance no can be calculated now. But reciprocals means what will happen now, 1 by of this no will be less no. So therefore when they are connected in parallel no, therefore R equivalent will be very smaller compared to the so all this combination, all individual resistance no. So when they are connected in the parallel, so equivalent resistance will reduce, R equivalent will reduce. Why it will reduce now? See here now, therefore here it will be like a area, therefore area of cross section is increasing now. When area of cross section is increasing, so R is equals to rho into L by A, so area is increasing, so the resistance will be decreases now. Clear? So in that way you can remember it now. So therefore here we can suppose if there are n identical resistors are there no, therefore suppose n identical resistors are connected in parallel. So if n identical resistors are connected in parallel, R equivalent no can be written as like a R by n. So current can also be written as, therefore current across each resistor no will be equal to total current divided by the n no. So this is the current no. So this is your R equivalent when they are connected in so identical resistors no, so are connected in parallel. So and here also one more important formula we can write it no. So suppose if any time two resistors are there no, are connected in parallel, this is R1 and R2, so they are connected in parallel no. So we can rewrite it as R equivalent multiplication of this one no, R1 R2 by R1 plus R2. So how I got this formula? So just this is one modification formula no. So if two are there no, therefore you can multiply, you can add it, therefore find the ratio, you can get your answer. But this will be only 2, but if it is more than 2, this is only the formula we have to use it. Clear? Right? So therefore this is your combination of the resistance no. So when they are connected in series and parallel no. So let us see some questions no. Now suppose if I give some 3 resistors, suppose here 3 resistors I am going to give no. So 3 resistance of each resistance is nothing but a 3 ohms. I am giving like a 3 resistance no, each resistance is 3 ohms no. Find the number of possible combinations no. Find the number of possible combinations and their equivalent no, also we can calculate no. Find the number of possible combinations. That means 3 resistors are there, how many ways we can connect it no, right? How many different ways no. So I will tell you last also I will tell you one formula no. 3 identical are there, therefore first one I can connect it is in the series no, and another one more I can connect it in the parallel no. I can connect it in the parallel and therefore here, So therefore 2 are in series, one is parallel now, and 2 are in parallel and with a series. So more than this one, no, you cannot able to expect it, no. Therefore here we will calculate the equivalent resistance, no. This is 3 ohms, 3 ohms, 3 ohms. So therefore, so R equivalent in this one now, just add up all this one now, therefore it is 9 ohms. Clear? So therefore here 3 ohms, 3 ohms and 3 ohms. So therefore R equivalent now can be written as, so 3 by number of 3, so 3 by 3, so this is 1 ohm. Clear? So this is 3 ohm, this is 3 ohm, this is 3 ohm. So these two are in series. Series means 6, no. Then these two are in parallel. So therefore R equivalent can be written as, so 6 into 3 by, it is 9, 3 ones are, so 3, 3, 2. Therefore 2 ohms will be your this answer. So this is 3 ohm, this is 3 ohm, this is 3 ohm. So what I can rewrite it as now, therefore here these two are, it will be nothing but 3 by 2, so plus 3. So R equivalent is nothing but 3 by 2 plus 3. So therefore it will be 6. So 9 by 2, therefore 4.5 ohms. Clear? So how many possible combinations are there? 1, 2, 3, 4. 4 possible combinations will get it now. Therefore how many combinations now? 4 possible combinations. Suppose I want to, okay, this 3 means is okay. Suppose if I give 100 now, how to calculate it now? So therefore you can use the one formula, very important formula, that is for 2 to the power of n minus 1 combinations are possible now. How many combinations are possible? So 2 to the power of n minus 1. When it will be possible? Are identical. Therefore when they are identical resistors are connected. Therefore how many identical combinations are there? How many resistors are there? 3. So n is equals to 3. So 2 to the power of 3 minus 1, 2 square, that is nothing but 4 combinations are possible here now. Clear? So this formula we can use it only for, so number of possible combinations if they are having identical resistors now. Clear? Same question we can go for this one now. Therefore next question, 3, so resistors which are not identical are given. Therefore what are they now? R1 is equals to 1 ohm, R2 is equals to 2 ohm, R3 is equals to 3 ohm. Suppose let is given now. So we have to calculate what? Find the number of possible combinations now. Number of possible combinations and find their equivalent now. Find their equivalent and draw the circuit diagram. How to do it now? So here not identical, not are identical no. Therefore here I can read them. First one is I can connect it is in series no, and another one is I can connect all they are in parallel. Clear? So these two are over now. Therefore here only it will be takes place no. Therefore here it will be added now. Therefore here right. So therefore here one more things are added now. Suppose here so one more thing now. Therefore here, so here right. So therefore here how many? Therefore here 1 ohm, 2 ohm, 3 ohm, 1 ohm, 2 ohm, 3 ohm. Here so 1, 2, 3. So here 3 is there, here 2, here 1. Therefore 2 means, so 1, 3, here 1 means 2, 3. Clear? So therefore here you can rewrite it as here 1, therefore 2, 3. Here 3 means here 2, here it is 1. So therefore here 1, 3. So therefore 2, 3. Clear? So these all are possible combinations. No? How many combinations are there? 1, 2. So this is totally 6, 7, 8. Therefore how many combinations are possible now? 8 combinations are possible now. Sir, here how to calculate it now? Therefore 2 to the power of n combinations now can be possible. How many not identical resistors are there now? So 2 to the power of 3. So therefore 8 combinations are possible now. In this way you can calculate the number of combinations. Clear? Right? So now here therefore we can calculate the R equivalent. No? So 1, 2, 3, therefore R equivalent is nothing but a 1 plus 2 plus 3, so therefore 6 ohms. So here 1 by R equivalent, no, therefore 1 by 1 plus 1 by 2 plus 1 by 3. So I can make it 6, no, 6, 3, 2. So therefore denominator is 6, no, so 9, 10, 11, therefore 1 by R equivalent. So R equivalent is nothing but a 6 by 11 ohms. Clear? So I think you can calculate it, no. Therefore here I will do this question, this question, remaining other things, no, you try it. Clear? So therefore here these two are in series, no. Series means 2 plus 1, 2 plus 3, this is 5, and this is parallel. R equivalent can be written as 5 into 1 by totally 6, no. So therefore 5 by 6 ohms. Clear? So here these two are in parallel. Parallel means 2 into 3 by 5, this is plus 1. So therefore 6 by 5 plus 1. So therefore here 5, so therefore 11 by 5. So this is your R equivalent. Clear? So 11 by 5 ohms. So I did not do these questions, no. So you try for yourself. Clear? So in this way you can solve the problems, no. Clear? Right? Let us see some questions, no, in this. Right. So this is first two questions are simple, I gave, no, very simple one, no. In a given circuit, no, find the equivalent resistance, no. See here, find the equivalent. How to calculate the equivalent now? Very simple. By seeing itself you can understand they are connected in parallel, no, sorry, in the series, no. R equivalent is nothing but a 3 plus 2 plus, 5 plus 2 plus 3, therefore it is 10 ohms. Equivalent resistance is nothing but a 10 ohms. What is the current it will be flowing? Current it will be equal to V by R. V is nothing but a 30 by 10. So 3 ampere, here 3 ampere it is flowing now. He is asking potential difference across each resistor, no. So what is the potential difference now? So their same current it will be flowing, no. So V1 can be written as, so therefore 3 into 5, so 15 volts. So across this one now, therefore V2, so 3 into 2, therefore 6 volts. So V3 is equals to, so 3 into 3, therefore 9 volts. Totally, so totally if you add of all these one, no, you will get it as, if you add of all these one, no, 30 volts you will get it. Clear? So in this way you can calculate it, no. Now let us see one more question, no. So therefore here two wires of equal diameters of resistivity rho 1 and rho 2 and length L1 and L2 respectively joined in series now. So equal diameters, therefore find the equivalent resistivity of the combination now. So that means here it is given as this is one equal area of cross section, no. Therefore here, so therefore here it is having L1, L2, therefore rho 1, rho 2. So area of cross section it will be the same, they are connected in series. So series means what you can write it now, therefore R equivalent now can be written as, so therefore R1 plus R2. But if you take it here now, this is your equivalent of this one now, therefore here length will become like a L1 plus L2. Clear? So rho equivalent resistivity, equivalent resistivity. So resistance can be written as R is equals to rho into L by A. So area of cross section it will be the same, there is not changing here, no. Therefore here, so rho equivalent into L1 plus L2 by A is equals to, therefore rho 1 into L1 by A plus rho 2 into L2 by A. So this A get cancelled out, no. Therefore so rho equivalent can be written as rho 1 L1 plus rho 2 L2 by here at no L1 plus L2. This is here rho equivalent. Rho 1 L1 rho 1 L1 So this it will be your answer. Rho 1 L2, this is minus, not there. Clear? So therefore here if they are connected in, okay, you do as a homework, no, if they are connected in parallel, so parallel, but here assume that L1 and L2 are equal. So find this as your homework, no, okay. So please do it and give in the comment now. Clear? Now we will go for one more question now. Okay. So this is one simplest question, no, very simple one, no. Later on we will go for a difficulty level. So in a network circuit, no, therefore find out the equivalent resistance. Now equivalent means what you will get it now, 1 by R is equals to, therefore 1 by 2 plus 1 by 3 plus 1 by 6. So I can make it 6 now, therefore this is 3, I can multiply 3, I can multiply 2. So 1 by R is nothing but a 6, therefore 3, therefore it is also 6 now. R equivalent will become like a 1 ohm. Clear? So therefore here what will be the current now? Total current now? Total current is nothing but a, so V by R equivalent. So 24 divided by 1, so 24 ampere. So here the current is nothing but a 24 ampere it will go. So here the current I1 and I2 and I3 is the current now, different currents. So I already told you, therefore currents are divided in such a way that the potential difference between them, it will be the same. Clear? So potential difference. So now we can rewrite it as how to calculate the potential difference now. So therefore potential, here there is no other part is there now, definitely across this one is also 24 volts only will be there. If any other resistors is there now, definitely the potential difference will be the different. Clear? So therefore here V is equals to, therefore I1 into R1, therefore it will be the 24 I1 into 2, that implies I1 is equals to, so 24 by 2, therefore 12 ampere no current it will be flows. So therefore here you can rewrite it as I2 is equals to 24 divided by 3. So how much now? 8 ampere no, it will be able to go through it. 3 ones are 8, 8 3s are 24. So therefore here I3 can be written as 24 divided by 6 no. So 12, 12, 24, 4 ampere no. Therefore if you add up all these one no, so you will get it as 24 ampere no, you are going to get it. These are the currents no across this each resistor no. Clear? So but here I am using this is 24 and also 24 here no. So because there is no other resistors are there, potential difference will be the same. But suppose any other resistance is there no, suppose let us see. Okay. So here this one question is given no, therefore you can see this question no, from this you can understand. So first what you have to calculate no, so equivalent resistance no, first so 2 3 6 no, I got it as already, so 2 3 6 here also 2 3 6 no, therefore equivalent resistance I got it as, due to this one no, it is 1 ohm. So 1 plus 2, therefore 1 plus 3 4 ohm. So current it will be equal to 24 by 4. How much now? It will be the 6 ampere. Clear? Current, what is the current is flowing here no? So 6 ampere current is flowing. Now 6 amperes it will come here no. Current I1, I2, so 6 ampere, I3, and this total it will come here no. Again 6 ampere current it will be flows. So now we have to calculate the potential difference across this one now. What is the potential difference across this one now? So here, so V is equals to I into R, so therefore 6 into 3, so therefore 18 volts. So across this one is 18 volts is there. So therefore in this 24 volts, 18 volts here only it is gone now. Rest of other volts, rest how many volts it will be there now? Therefore 24 minus 18. So therefore here 6 volts it will be there no. So this it will be the 6 volts will be the across this one. Clear? So across this one 6 volts, across this one 6 volts, across this one is 6 volts, not 24 volts. So previously this part was not there, that's why we took it as like this no, but this part is there, therefore the potential difference across this one is different. Clear? So now across each resistor is nothing but how much no? So V is equals to I1 into R1, So 6 volts, it is I1 into 2, therefore I1 is equals to 6 by 2, 3 ampere. So this I1 is nothing but a 3 ampere. So therefore, so here I2 is equals to 6 by 3, therefore 2 ampere. I3 is equals to, therefore this is now 6 by 6, 1 ampere. Add up all these one, you will get 6 ampere. This is your 6 ampere. Clear? I think you got the clarity. So all the questions, no. So these type of things, no, you should keep in mind. Clear? Now we'll go for another new question. No? Let us go for this. So therefore, find equivalent resistance, no, across AB and across AC. Clear? So across AB we want to calculate. AB means here how much now? This is your AB. So that means when the current is flowing, coming here, current is getting divided here, no. So but the same current it will be flowing here, no. Therefore these three are in series and these two are in parallel. I mean this combination, this is in parallel now. So therefore here I can rewrite it as RAB can be written as these three are in series now. Therefore it is nothing but a 3R. So 3R is parallel to R. Clear? So 3R into R by, therefore 4R get cancelled out, no, 3R by 4. So resistance is AB is 3R by 4. Now we want to calculate across AC, therefore across this one, no, across this. So if you come here, no, current it will be get divided, no, comes here, no, therefore it will be goes like this, goes like this, goes like this. So therefore these two are going to combine here, no, therefore RAC. Clear? So in this part, no, therefore now in this part, no, therefore here, so these two are in series, no, these two are in series and these two are in parallel. So RAC, 2 are in series means 2R and 2R, so 2R by 2R, so therefore and 2, okay, so 2R, okay, 1 minute, therefore here, so therefore 2R by 2 you can write it as 2R by 2, so because both are identical, no, therefore it will be the R, it will be your equivalent resistance. Clear? Right. So now we'll go for another question. Right. Equivalent resistance across AB. So across AB, what you can write it now? Therefore here, so these two here junction is there, no. Therefore here, so these two are in series and these two are in series, no, and these two are in parallel. Therefore these two are 3 ohms and these two are 6 ohms. So what you can rewrite it as now? Therefore here, so 3 into 6 by 9, 3 ones are 3, 3 ones are 3 twos are, therefore 2 ohms. So across this one is 2 ohms, this one is, these two are in series, these two are in series and these two are in parallel. This is your 6 ohms, this is your 12 ohms. This part is how much now? This part, right? So these two parts are in parallel. Then what you can write it now? 6 into 12 divided by 18. 6 ones are 6 threes are 3 ones are 3 fours are. Therefore across this one is 4 ohms. So how it will be get it now? Therefore across A, this is 2 ohms, this is your 4 ohms. RAB is equals to 6 ohms. Clear? Clear? So now we'll go for another question. Find the equivalent resistance for AB and AD. Okay, AB and AD. So AB, so therefore we'll do for AB across this one. Across this. Clear? So suppose if you connect the one battery here, no, current it will go and it will get divided here, no, current get here, no. Therefore here, so when current it will go here, no, there is no other part is there, therefore current it will be come to here only. So the current will not flow through this one, no. These two are in like a open circuit. So open circuit means the current will not pass through this part now, this part can be neglected here now, we don't want this part now. So when you are calculating now, therefore this equivalent resistance it will become like this. So this is A, so I am rewriting now, this is R, so this is R, this is R, this is R, 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 this is B. Clear? So therefore here we are reconnecting now, these are the three. So three series now, same current it will go here no, same current no. So therefore these three are in series no, therefore it will become like a 3R, and these two in parallel no. So across this part no, we can write it as R dash, it will be equal to 3R into R by 4R, it cancel out no, 3R by 4. So this part totally I got it as, now this part can be written as, so R 3R by 4, it is R. So what you can write it now? So we will get it as R plus R, therefore it is 2R, and therefore RAB can be written as 2R plus 3R by 4. So therefore 8, 9, 10, 11 R by 4. So ohms no will be your RAB. So now suppose if they are asking RAD. So now here in AD means, so we can we'll see it now. Now we'll go for RAD. I can redraw this ray diagram no, sorry, circuit diagram. Therefore here next question no. So this is your A, B, C, D. So it is D. Clear? So this is C and this is B no. You try to see this one now. Here current it will be, okay, we are connected no. Therefore current it will go, and this it will be able to go through it no. Therefore here this side it will be the open circuit no. This is like a open circuit. Current it will come here no, reach to this point. So current will come here no, will reach to this point no. Therefore this one. So these are like an open part of this one no. Therefore the effect of these two resistors no can be neglected no. Therefore what I can do it no, just I can eliminate this resistor no, I can remove this resistor. Now the circuit it will become like this. Now therefore these two are in parallel, R and R, sorry. So these two are in series, these two are in series, this is 2R, 2R. So therefore and these two are in parallel, 2R by 2, this is R. Therefore it will become like a, this is R, this is R, this part is also R. So therefore AD, so RAD can be written as, therefore 3R will be your answer. So therefore go through it no. Therefore if you are getting any confusion no, just to check it one more time, right. So think right, you got the clarity. So which part is about open circuit now? Clear? Now we'll go for another question now. So we have to calculate the current supplied from the battery. Therefore current, how much current it will be able to flow through it. So this is looking very difficult no, but it will be very easy only. So don't panic by seeing the circuit no, just observe it, right. So here you try to see it no. Therefore this point no, this is the battery. So this part you can try to see. So here this part no, therefore these are in series, and these two are also series and parallel. So this part is in series, this part in series and parallel, and both parallels are connected to the battery here now. Clear? Now so therefore here how many are there now? This is 4, this is 4, 4, 4. Therefore how many it will be then now? 4 resistors or 4 are there no. Therefore this part is nothing but a 4 into 4, therefore 16 ohms. So these two are in therefore series no. Therefore this is nothing but a 4 ohms. Clear? But these two are in said to be like a parallel. Okay. Now let us see, this side is also 4 ohms, this is nothing but 16 ohms. So just I will redraw this circuit, no. Therefore, how it is there now? This is nothing but 16 ohms. So therefore, this is 2 ohms, sorry, this is here 4 ohms, and here the battery is there, no, 16 volts. So again this is nothing but this part, no, 4 ohms, again this part is nothing but 16 ohms. Now you try to see it, no. Therefore, if I try to flip it here, no, so therefore these all are in parallel, clear. So therefore 1 by R equivalent, no, can be written as 1 by 16 plus 1 by 4 plus 1 by 16 plus 1 by 4, clear, R equivalent. So therefore I can make it this as 4 into 4, therefore into 4 into 4. So therefore 4, 4, 8, 9, 10, therefore 10 by 16, 1 by R equivalent. So therefore R equivalent is nothing but 16 by 10, so 1.6 ohms, clear. So now just we can got it as, therefore here I got it as one battery here, no, therefore 1.6 ohms, 16 volts. What will be the current here now? Therefore current, no, current it will be here. So current can be written as 16 volt divided by 1.6, no, therefore 10 ampere, no, current it will be drawn from the battery. So by seeing the circuit, no, therefore don't panic, just observe it, no, so that you can able to solve very quickly. Let's see some questions, no. Here find the equivalent resistance across OA. Across OA. So we want to calculate in between these two. Clear? So how are they now? Therefore here these two are in therefore here is in series, no, and this is in parallel. This is series means what? 6, no, 6 by 6 it is 1, clear. Sorry, here it is nothing but here it will be, so this is 6, so both are 6 are in parallel, 6 by 2, so therefore 6 by 2 is nothing but 3 ohms. So this will become like a 3 ohms, and this part it will be 3, so 6, no, again 3, again 6, 3, again 6, 3, again 6, 3, 6, therefore here it will be the 6, therefore this is nothing but 6, 3, so this it will become like a RAO, it will be nothing but 6 into 3 by, so therefore 6 plus 3, so 6 into 3 by 9, that 3 1s are 3, 3s are 3, 3 2s are. So 2 ohms will be your answer, clear. Now we will go for one more question, no? So here now, so potential difference between A, B. So he is asking what is the potential difference between A, B. So for this, no, current is required. Here the current it will be flowing about 1 ampere, no, 1 ampere. So when it is 1 ampere it will be there, no. Therefore here, so across this one, no, potential difference it will be equal to, so V is equals to IR, therefore it is nothing but 24, clear. So that means what is the potential difference here now? So across all these one, no, therefore 24 volts will be your potential difference now, clear. You understand, no? Potential difference across this one, no? Clear. So 24 volts, no, therefore here also 24 volts, no, here also current it will be 1 ampere. So here it will be how much now? So current across this one, no, current it will be equal to I is equals to 24 by 6, no, therefore 4 ampere, 4 ampere across this one now, therefore here it will be the 6 ampere, here it will be nothing but a, so 12 ampere. So total current it will be equal to how much now? Total current, whatever the current which is coming here, no, current. So here current, no, therefore here 12 plus 6 plus 4 plus 1 plus 1. So therefore here 12, this is 10. So this is nothing but a 10, 12, 12, 24. Current it will be equal to 24 ampere now. Clear? So therefore here what you will get it, no? Therefore here, no, therefore here current and this total equivalent resistance, no, right. So this is 2 ohms, this is nothing but a 4 ohms. Equivalent resistance is how much, no? So therefore here 1 by R equivalent is nothing but a 1 by 24 plus 1 by 24 plus 1 by 6 plus 1 by 4 plus 1 by 2. So 24 I can make it, no? Therefore here it will be the 4 I can make it, here 6 I can make it, here 12 I can make it, no? So therefore here 12, therefore this side is 24, this is 2, 12, 12, 24, 1 by R equivalent, no? So R equivalent is nothing but a 1 ohm, therefore this it will be the 1 ohm. So current across this one, no, A to B, current how much, no? Current it will be equal to 24 amperes. So potential difference between AB can be written as V is equals to I into R. So 24 into these 3 are in series, no? Therefore here, so series means it will be nothing but a 7. Clear? So what will be the 14, 14, 28 to 14, 15, 16, 16 volts. 168 volts. Clear? Na? So 168 volts, no? In this way you can solve it, no? Therefore you try like this, so that you can get the full clarity in this type of questions. No? Clear? Now we will go for one more question. No? Yeah, here one new learning is there. No? Suppose before this one, no, we will go for some simple thing. No? Suppose there is one wire is there, this is one wire, so therefore here wire is there, no, whose length is L. Now what I am going to do now, therefore I am going to divide into, so we can do like question, no, I am divided into like a 2 pieces, suppose I am doing 2 pieces, no, so length will become like a L by 2 and L by 2, this total initially resistance is R. Now I made into 2 equal pieces, no, therefore resistance what will happen now, R by 2 and R by 2, clear? So when I am doing divided into 2 equal pieces, R by 2. So therefore like that, no. Okay, we can add one more question. Suppose this is having length is L, so having equivalent resistance, no. Therefore what we are going to do now, so now we are going to divide this one now n identical parts now. So when it is divided into n identical parts, no, each resistance what will happen now? Each resistance will become like a R by n. So if n identical parts are connected in parallel, if they are connected in parallel means what? Therefore here this one part, another one more part. So one part like this, no, we are connected into this one now, n identical parts now. So now what will we want to calculate? What we can calculate? R equivalent, no. So that is nothing but a R by n, R by n, R by n, R by n. How many parts are there? No, n parts are there. No. So R by n parts, no, R by n square will be your answer for this one. No. Clear? So one more part, no. Suppose here now, so same type of, no. Therefore suppose here this is one circular wire is there, no. Suppose it is having resistance is R. Now what we are going to do now? We are going to divide into 2 equal parts now. We are going to connect it like this to the battery here now. Now what happens now here? So we are dividing this one into 2 parts here, no, 2 parts, no. So therefore here this total resistance is R. Each part what will happen now? R by 2 and R by 2. But how they are connected now? Current it will becomes here, no, current it will be get divided, no. This R by 2 are parts are divided into 2 parts, no. So therefore R equivalent will become like a R by 2 by 2. So R by 4 will be your equivalent resistance. If they are asking what will be the current, no, current it will be equal to V by R. So V by R by 4. So that is nothing but a 4V by R will be your answer. So diametrically opposite now. Therefore where you are going to do now? We are going to connect it along the diametrically opposite. So like that, suppose if it is this is one wire is there, no. Therefore what you are going to do now? So I am going to connect it at this point now. Therefore this part, making an angle theta at the center here now, theta at the center. So therefore this total resistance is R. So therefore here what is this part? No, this part, no, we can rewrite it as. So this part, the length of this part, no, we can write it as length in directly proportional to R. This total is R, no. So this R part, suppose this is your R1 and this is your R2. R2 part I can write down theta by 360 into this total length, I mean this part, no, therefore it will be R, it will be our answer now. And remaining other part, no, therefore, so suppose I will take it as 60 degree, so what I will get it now, therefore 60 by 360 into R, so therefore here 6, no, therefore R by 6, no, remaining other part, no, what will happen now, total R minus R by 6, no, so there is nothing but a 5R by 6. So how they are connected? No, they are connected in parallel because they are connected the battery here at this point, no. So battery at this point, so R equivalent, no, can be written as R1 into R2 by R1 plus R2. Clear? So in this way you can solve the problems, no, for any angle now. Clear? So now let us see, come back to this question, no? Right. What did he says now? He says that the resistance of the wire is 6 by pi ohms. Therefore, he did not give what is this one now. 6 by pi ohms is in the form of like a circle loop of radius is 1 meter. So, therefore, find the equivalent resistance across this one now, diametrically opposite. So, this part now, therefore, what is the total resistance now? Total resistance we can write down. So, total resistance is nothing but total resistance of this one, no, of single wire, no, can be written as, this is given as resistance per 6 by pi into total length of this one is nothing but 2 pi into R. So pi cancel, no, therefore it is 12 into R, but R value is 1, no, therefore 12 ohms. Clear? So this total was 12 ohms. Now what they are doing now, we are connecting diametrically opposite at this point. Clear? So that means this it will become like a 6 ohms and this it will become like a 6 ohms because opposite divided by two parts equally. Now therefore here, so RAB is nothing but a 6 by 2, therefore 3 ohms will be your answer. So you need to think like this fastly so that you can do the questions very easily. Clear? Now we will go for one more question. Here I gave this question, I gave. Right. So therefore here a uniform wire of resistance, this total resistance is given as 18 ohms, is bent in the form of a circle, effective resistance between A and B. Therefore here theta is equal to 60 degree. So total resistance is 18 ohms. So this is 60 degree means what will happen now? This is suppose R2 and this is R1. R2 is equals to theta by 360, therefore 60 by 360 into 18 ohms, no, therefore this is 6, so this is 3, so therefore 3 ohms will be your this part. Clear? So this is 3 ohms means compulsory 18 minus 3, therefore this is nothing but 15 ohms. But if how they are connected now, they are connected in the parallel to this. Clear? So therefore here AB can be written as, so 3 into 15 divided by 18, so 3 plus, right? So 3, therefore 6, so 3 2s are 3 5s are, so 2.5 ohms will be your answer. Clear? So now we'll go for another question. Calculate the effective resistance across AB. Across AB is asking now, right? So this is your right connected now, therefore this is connected. You try to see this one now, this is one wire, simple wire now. So for a design purpose only it is given now. What is the need of this wire now? This is need of the wire is not there. So this is just simple one now. Therefore this is connected at this point now. This also connected to be at this point now. This also should be connected to this point here. So this simply I can rewrite it as, this is nothing but a part. So this is your R, this is your B part. So this part, no, this A is connected at this point, no. Why I should connect? This is simple wire only. This is wire. So wire does not have any resistance, no. It acts like a short one, no, right? So therefore this is one, right, R, and this also it will be the R, and this also it will be the R, right? So how many are there? 1 2 3 4, therefore RAB can be written as like a R by 4 will be your answer. Clear? Right? So now we'll go for another question. So two wires of same material and length. So same material and length having the cross section in the ratio of 1 by 2. Same material and same lengths having the cross sections. Therefore, area of cross section, therefore A1 by A2 is given as 1 by 2. So lengths are same, materials are same. Now a thin wire is cut into 3 equal parts. No, therefore thin wire means A1 part. So right, cut into 3 equal parts, arranged into form like a bundle and connected in series with a thick wire. Therefore, if the resistance of the thick wire is 18 ohms, and find the resistance of the given combination. Now, clear? So therefore here let us calculate, so R is R1 by R2. So 1 I can take it as like a thin wire and R2 taken as like a thick wire. So it is inversely proportional to the area. Therefore inversely proportional to the area means A2 by A1. So therefore here what I can rewrite is now, so A2 by A1, therefore 2 will be your answer now. So R1 will be equal to 2 times of your R2. Right. So therefore here okay, right. So therefore here area of cross section is smaller now. So this is, we can call it as like a thin wire, and this is nothing but like a thick wire. Clear? So thick wire will be having low resistance, right? Thin wire will be having high resistance now. So now this one, this wire is cutting in the form of like a 3 equal parts now. Therefore this one will become like a some R1 dash, it will become like a 3 parts now. Therefore R1 by 3 and arranged to form like a bundle in the series. Therefore what you can write it now, R1 by 3. So cutting and bundle forms a bundle and connected wire. Okay, this is a bundle means what? So this is one thin wire is there now. So this is connected, made into 3 equal parts now. So therefore what will happen now, this will become like a R1 by 3 and connected in the form of like a parallel. Bundle means parallel now. Clear? So R1 by 3 by 3 means, so R1 equivalent, no dash is nothing but a R1 by 9. So this R1 by 9, so this bundle is connected in series with a thick wire, right? So thick wire is nothing but a R2. This is R1 by 9. Clear? So if the resistance of the thick wire, so this thick wire is given as 18 ohms. Find the given resistance in this combination now, right? So this is 18 ohms means R1 it will be equal to 2 into 18. So therefore it will be how much now? So 36 ohms. Clear? So now therefore R equivalent now, therefore R1 by 9 plus 18. So therefore 36 divided by 9 plus 18. So how much it will be now? So therefore 9 ones are 9 fours are 4 plus 18, therefore 22 ohms. So this is your combination, no? I think this is your 22 ohms will be your answer. I think you understood. Clear? So lot of information is there, no? So you can learn. Next one. So here, if the circuit is short circuited between A and B, what will be the current supplied by the source? So short circuit means what you have to do, no? What you should understand, no? Short circuit means just connect one wire. So therefore here always remember that current will always choose to flow like a low resistance path and make like a closed circuit. So low resistance path, it does not want to flow along the high resistance path now. So now what will happen now? The current, whatever the current is there, so it will come here and it will go to here. What is the need of going to this one? Therefore the current will not be able to flow through this. So now this circuit will become like now like this now. So this is one resistance R. Short circuit means there is no resistance, no. So this is also R. This is now potential now. Now therefore current drawn from this one now, I is equals to V by R equivalent. So these two are in series now, V by 2R will be your current. Clear? Right? So now we will go for another question now. Right? So here therefore find out the equivalent resistance between AB. AB is there no. So how it is there now here? Okay. Try to observe. So here this part is there now. This part is nothing but like some simple one circuit wire. So now therefore here the current it will come now. The current it will go to here, go to here. So comes to here now. Therefore here it will be also comes to here. So what is the right after coming here now? Definitely it has to come to here now. Come to here. So therefore it will go to here. So why it has to go here now? Therefore it will go to here, go to here, go to here, go to here and go to this point. Clear? Therefore this part is short circuited. That part can remove it, right? So therefore here what we can just we can rewrite the circuit no, resistance between AB. Okay. So we can rewrite the circuit no. This is R. Here R. Here R. Now this part no, just one wire is there. So this is R, this is the B. Clear? So this is your circuit now, it is becomes like a simple here now. Now these two are in series and this is in parallel to this one now. Therefore here series means this will become like a 2R. So therefore 2R into R by therefore 3R. So therefore here one R get cancelled, 2R by 3. So therefore here now the circuit now it will become like this. 2R by 3, therefore R, A and B. R, A, B can be written as 2R by 3 plus R. So therefore 3R, therefore 5R by 3 will be your answer. Clear? So therefore here looks like complicated no, but it will be very very simple one. Clear? So now here we will go for one more question. So find out the equivalent resistance between A and B. So A to B we have to come now here. We have to come to here now. These all parts are there, we come to here. So this part is no use and this part is no use. Clear? So because we want to calculate between A, B here. So this is your outer part now, just remove this one now. Then how it is then now here. So now this part, these two are in series and parallel. Clear? So these two are in parallel. Okay. Now here current is coming here no. Okay, one more some part is also is there here no. So some current it will be coming here no, coming here. So this also coming here, coming here. Why this current has to flow? Current it will flow here no, current it will be comes to here. So therefore this part is also got neglected. Clear? Right? So therefore simply we can draw the circuit no. Therefore here this is your 2 ohms, 1 ohm, 2 ohms, 6 ohms, 2 ohms, 3 ohms. This is the our circuit no. Now what you can get it now, these two are in series. So therefore this is 3, these 3 are in parallel. So 1 by 3 plus 1 by 6 plus 1 by 2. So 1 by R. So I can make it 6 now, therefore 3, this is now 6 I can make it no, therefore 3, 5, 6 no. So R equivalent is nothing but 1 ohm. So due to this one is 1 ohm, so I can rewrite this one no. So this is 2, this is 1, this is 3, A, B. So R, A, B can be written as 6 ohms will be your answer. Clear? So 6 ohms, right? So now we'll go for another question. This also similar type here, no? Therefore I think we already discussed here, no? So resistance between AB is given, no? So across this one, no? There AB, yeah. Okay, okay. Huh? Right, AB. So now we can come from here, no? These two are in series and parallel to this one, no? So 6 by 2, therefore 3. So this part it will become like a 3 ohms. 3 plus 3 again 6, no? Again this part it will become like a, so 3 ohms. Again 3 plus 3, 6, no? So 6 by 2, again this part it will become like a 3 ohms. So therefore here it will become like a, this is 3 ohms and this is also 3 ohms. So therefore here it will be the 3 ohms, AB. Now here these two are in series, no? Therefore RAB. So series means 6 into 3 by 9, 3 1s are 3 3s are 3 1s are 3 2s are. So 2 ohms will be your answer. Clear? I think we did this type of question already. Now we'll go for this one. So here in this one, no, there is a Wheatstone bridge is there, no? Right? I will tell you one shortcut for this one, no? Wheatstone bridge, okay, Wheatstone bridge, no? Actually we'll do one separate video, so based on the Wheatstone bridge, no? But I'll tell you one small shortcut, no? So therefore here there is a, this is one Wheatstone bridge, no? Therefore there is a galvanometer, so therefore this is your Wheatstone bridge. Suppose these all resistors are same, so R and R, this also R 10, anything, this one is whatever may be that, no? So R equivalent will become like a R ohm only, keep in mind. So therefore I will teach you this concept, no? Therefore Wheatstone bridge, no? So Wheatstone bridge, so as a separate video, right? Separate video, no? Just go through it. Here there is a two Wheatstone bridges are there, no? Here this circuit diagram is also Wheatstone bridge, no? So this R, no? Therefore this it will be nothing but a, so R equivalent is nothing but a R only. Here this is also Wheatstone bridge only, so therefore this equivalent resistance is also nothing but a R only. Clear? Keep in mind. So apart from this, other questions are there. Clear? These two questions are R ohm. Now we'll go for this one, no? Is asking this, so I think, right? So across AB, no? So this is R and R, therefore here it will be the 2R. Okay, this is not a Wheatstone bridge, no? So this is 2R, so 2R, therefore here, and this to be parallel with this one, no? Therefore 2R into R by 3R, so this will get cancelled, 2R by 3. So this part it will become like a 2R by 3. And this is added to this one, no? Plus R, therefore 5R by 3, and this is parallel to this, therefore RAB is nothing but a, so 5R by 3 into R by 5R by 3 plus R, therefore this is nothing but a 5R into R by 3 by 8R by 3, so R by 3 get cancelled, 5R by 8. So this answer it will be nothing but a 5R by 8 will be your answer. Clear? So now this part, no? This part we will do it, no? Let us see. So also I told you, therefore this is one simple one, right? One simple one connecting wire, no? So these all are connected to at this point, no? Therefore I can do as like a second part, no? Just to redraw the diagram, no? Right. So here this is here A and all are connected to this point now. this is B part, this is A part, R. So this will become like R by 3. So R AB is equals to R plus R by 3. So therefore 4R by 3 will be your answer. Clear? So, and this question I already discussed. So so just go through it, no, these questions. Clear? Right? Now we will go for one more question. No? So 13 resistors of resistances R is connected in this one, no? Therefore effective resistance between AB. So now we want to calculate the resistance between AB, right? How to calculate it now? This is looks like a symmetry circuit now. Therefore, how the symmetry is there now? Therefore, here I can just try to draw this. So this is here nothing but a symmetrical axis here now. So any resistance or anything, any circuit now, if they are in symmetrical resistance, no, their potential it will be the same along the symmetrical axis, no, potential will be the same. So therefore current passing through this one, it will be the 0. So resistance is nothing but a, so ineffective. So ineffective means what you can write it now, we can remove it. Yes, sir? So therefore you can see, you can divide this on exactly the two parts of this. Clear? So therefore symmetrically, so we can use it, no, this is one symmetry. Now here this resistance, no, can be neglected. Clear? Can be removed. So then how the circuit it will become now? Therefore, so this part, no, this part is in series and parallel. So now here, so series means 2R and it is 2R into R by, so 2R plus R. Therefore here 2R by 3. So this part, no, this is part is A. So this part, no, 2R by 3 and this part is also same, 2R by 3 and this part is also same, 2R by 3. This part is also same, 2R by 3. Clear? So this is forming like a again Wheatstone bridge like this, no. So this is nothing but a R. Clear? So this is forming like a Wheatstone bridge, no. Therefore I told all are same, no. So RAB will become like a 2R by 3 ohms. This is your answer. Clear? So right. So now we'll go for another question. Right. We'll solve this question now. So the voltmeter reads 18 volts now. Therefore here 18 volts will be your this one now readings, no, across this 50 ohms. That means across this also it will be the 18 volts only. Clear? So find the resistance of the voltmeter. Resistance we want to calculate. So here therefore here 18 volts means across this one how much now? So 30 minus 18 means it is 12, no, 12 volts. So 12 volts means here current flowing through this one now, current it will be equal to, so current it will be equal to 2 ampere. Clear? So current through this combination also should be the 2 amperes, no. Therefore here, so we can rewrite it as like a, therefore V is equals to IR, R equivalent of this part. Therefore potential we got it now 18 volts, current is nothing but 2. So therefore R equivalent is nothing but 50 into R by 50 plus R. Why? Both are connected in parallel here. So therefore here it will be the 9. So therefore 50R can be written as, therefore 9 into 50 plus R. So 50R it will be equal to 450 plus 9R. So taken here now, therefore 450 minus 1 minus 9 means 41. R is equals to 450. R is equals to 450 by R. Sorry, 450 by 41. So this it will be your resistance now. Clear? Resistance of the voltmeter. Clear? Now we will go for another question. No? Right. So here most of the students know what they will think. No, they will think that it is okay. We want to calculate the R1. So bit 1 it is given as okay. So this is given as 6 ohms. Across this one is 6 ohms. So we want to calculate R1. Most of the students, what they will take now, they will take off all this. Therefore they will take it here now. Current it will come here now. See, you try to see this one now. The current it will be goes here now. Compulsory this has to go to here to here. So but here the current also it will be able to go through from here to here no. So therefore from here, so why it has to go from here to here now, therefore it cannot, no need to go to here no, it will go to here, it will go to here, therefore go to here now. Clear? Right. Therefore it need not to go to across this one now, need not to go to across this one now. Clear? So that means here two parts now can be short circuited here now, right? Sir, here most of the students they will take this only the short circuited, but this will they will take it no, no, from here to here no. Now the circuit what will happen now, it will become like this. So therefore here this it will be the R, and this is nothing but I think it is 1.5 or 15, I am not understanding, but I will take it as 15 ohms. So here I will take it here now, therefore this is A, this is B, so this is given as 6 ohms. So we want to calculate no, these two are in therefore parallel, so therefore 6 is equals to 15 into R by 15 plus R, so taken here now, so 6 into 15 plus R is equals to 15R, so 3 2s are 3 5s are, so therefore here to 30 plus 2R it will be equal to 5R. So taken now 30 is equals to, so therefore it will be 3R, so therefore R is equals to 10 ohms. Clear? So this should be your answer. Clear? Now right, so I think I covered most of the concepts, most of the different type of problems no. So minimum basic level no, you should know this, right? So later on, so we will come with one difficulty questions no, the videos, and solving the circuits no, very large circuit no. So we will see. In coming topics no, we will discuss so Wheatstone bridges and Kirchhoff laws no. So this all we will discuss now. Clear? So thank you for watching. Please subscribe to my channel. So please share our videos no, those who want to learn the physics very easily.